In this lesson, we're going to learn how to simplify and evaluate expressions that involve exponents. And what we're going to have to do in order to simplify and evaluate these expressions is we're going to have to apply the laws of exponents. So right down here, we have summarized the various exponent laws that we've learned in class. Now, I'll just go through them and give you a quick little example of each one, and then we'll move on to the examples. So the first law says that if you have two bases that are identical, they're being multiplied together, and both of these bases have an exponent, in this case m and n, we can just add the exponents to get the right answer. So for example, if we had 2 cubed, and that was being multiplied by 2 to the 4th power, then we would just add the exponents, and that would give us an answer of 2 to the 7th power. When we're dividing, we're going to take a look at the bases and make sure that they're identical again. And this time we're going to subtract the exponents. So if we had two bases, let's say it was 3 to the exponent 5 over 3 to the exponent 2, or 3 squared, well, we will just go ahead and subtract the exponents. So we would get 3, and then 5 minus 2 would give us an exponent of 3. Well, what do we do when we have an exponent raised to an exponent? Well, the rule is that we multiply. So if we had something inside the brackets, let's say it was 2 to the exponent 3, and that entire base is being raised to the exponent 4, well, that would mean that we just multiply the exponents, and we would have 2 to the exponent 12. Okay, take a look at this next exponent law, and it tells you that if you have multiple terms inside brackets and they are all raised to the exponent, in this case n, well, just remember that that exponent applies individually to those terms as well. So let's take a quick look at an example. Let's say inside the brackets we had 3x, and then all of that bracket was squared. Well, the 3 is squared, and the x is squared. And normally we would obviously write 3 squared as 9, so we would have 9x squared as the actual value. So just make sure that the squared, the exponent on the outside, applies to every single term inside. Okay, what if we, instead of having a product inside the brackets, what if we have division? How do we handle something like this? Well, this is just reminding you that if we had something in the neighborhood of, I don't know, 5 halves, and all of that is being squared. Okay, well, that is the exact same as saying I have 5 squared over 2 squared, which is 25 over 4. And certainly if we had just written 5 over 2 times 5 over 2, which is 5 over 2 squared, we would get 25 over 4. So just remember that, again, when you have multiple terms inside and they're expressed as a quotient, that we can apply the exponent to each one individually and get the same answer. Okay, anything, absolutely anything with an exponent of 0 is equal to 1. And what do we mean by anything? Well, let's say we had x to the exponent 0, that's equal to 1. What about 17 to the exponent 0? That is equal to 1. What if I had 3x squared y, all of that to the exponent 0? Well, it doesn't matter what the base is. Any base to the exponent 0 is equal to 1. Okay? And last but not least, if we have a negative exponent, if we move that base from the numerator into the denominator, or vice versa, the exponent will change sign. So for example, if we had, I don't know, 2 to the negative 3, well, it just means that let's move the 2, the base, into the denominator, and that exponent will now turn positive. Okay, so 2 to the negative 3 is the same as 1 over 2 to the positive 3. Similarly, if I have a negative exponent in the denominator, so for example 1 over 7 to the negative 2, Well, if I move that base up to the top, the exponent turns positive. Okay, and you can see that when we have fractions. So for example, if I had 3 halves to the negative 1. Well, if we take a look up here, remember that rule right there that said if I have a fraction and I have it all raised to an exponent, it can be applied individually. Okay, so that means that if I was applying this individually, I would get 3 to the negative 1 over 2 to the negative 1. And that would just mean that not only is the 3 in the wrong place, if I move the 3 from the numerator to the denominator, I would have an exponent of 1, but also the 2 is in the wrong place. If I move the 2 from the denominator back up to the numerator, that negative 1 will turn to positive 1. So, in fact, this is just 2 over 3. Okay, so there's the exponent laws we're going to apply over these next two questions we're going to take a look at. We're going to look at an example that asks you to simplify, and then a couple of examples that ask you to evaluate. But these are the exponent laws that we're going to be relying on in order to get our answers. Okay, let's move ahead. Okay, in this question, we're simply asked to simplify, and it says express the answer with positive exponents. So when we're all done, we're going to want to make sure all of our exponents are positive. Simplify just means to take something that looks fairly complicated and write it in a simpler manner. We aren't solving for any variables. We aren't evaluating, which just means to come up with an actual answer. We've got variables in here, so at the end we're still going to have variables. It's just going to look a whole lot simpler. Well, let's take a look and start applying some of these exponent laws that we know. We have negative exponents in there. We have exponents raised to other exponents. I have an exponent of 0 in there. Okay, so we've got a lot going on, but we'll just be very methodical. We'll follow the bedmass rules, which tell us to work with brackets and exponents first, and then multiplication, division, and we will just step by step come up with a simpler answer. Okay, all right, well, let's go ahead and get started. First thing I'm going to do is I'm going to take care of the first bracket here on the top, and we're going to say that, all right, this exponent of 2, this squared, is applied to every single piece inside individually. So 5 squared is 25. X to the negative 2, well, when I have an exponent raised to an exponent, I multiply, so that becomes x to the negative 4. Y cubed squared is, again, multiply, y to the 6th power. And I'm just going to put brackets around that. I've now removed that exponent of 2, but I've got this whole term just like that. Okay, the next term, the 2xy to the negative 3. Well, that has a negative exponent on it. And I'm going to move that down into the denominator before I start handling it. I'm going to work with positive exponents whenever I can. It just makes it a whole lot easier. So I'm going to go ahead and move that in just a moment. Looking down at the bottom, I've got 3xy to the 0. Okay, so those exponents are positive. But I notice that y to the exponent 0, I'm going to have to handle that as a special case when we get to there. And then I'm going to look at this bracket right here. 7xy cubed, it's all raised to the exponent negative 1. Again, a negative exponent, so it's in the denominator. If I move it up to the numerator, it'll turn positive. So I'm going to go ahead and do that right now. I'm going to move the 7xy cubed up to the top, 7xy cubed, and when I do that, the exponent outside changes from negative 1 to positive 1. And, well, this whole thing raised to the exponent positive 1 is just that whole thing. So there is the top of the fraction. Okay, well, let's work with the bottom now. Now, looking at the first term, 3xy to the exponent 0. Well, anything to the exponent 0 is 1. So when I take the base y and raise it to the exponent 0, essentially that is saying 3 times x times 1, which is just 3x. Okay, now remember that negative exponent we had up top. We had 2xy to the negative 3. So let's bring that back down to the bottom. So 2xy, and that negative 3 turns to positive 3. Okay? All right, so there's the four sort of pieces, and let's go ahead and just start cleaning up and multiplying the top and multiplying the bottom, and we'll then start collecting terms. Okay, so 25 times 7, well, that is 175. X to the negative 4 times x, and there is a 1 there. Well, that's negative 4 plus 1, which is x to the negative 3. Y to the power of 6 times y to the power of 3. We add the exponents. That is y to the power of positive 9. All right. We've got 3x. And this whole bracket is cubed. So we've got 2 to the exponent 3, which is 2 cubed, which is 8. X to the exponent 3, x cubed, and y to the exponent 3, y cubed. All right, well, let's go ahead and just clean up the bottom a little bit here. We'll stay with the top, 175 x to the exponent negative 3, y to the exponent 9. And then on the bottom, 3 times 8, 24. X times x cubed. Now remember, x has an exponent of 1 there. So x times x cubed, add them. X to the exponent 4. And then just the y cubed. Okay, let's continue our answer up here. So when we do division, remember the exponent law says when you divide, we subtract the exponents of bases that are the same. So up top, we're going to have 175, and then down on the bottom, we're going to have 24. Okay, so x to the negative 3, subtract 4 more, gives me x to the negative 7. Y to the 9th exponent, and then I subtract 3 because I'm dividing by y cubed, is y to the 6th exponent. All right, almost done. The last step is quite simply, let's take care of this positive exponents requirement. So x is being raised to the exponent negative 7. If I move that down to the bottom with the 24, the exponent will be expressed as a positive value. So 175 y to the 6th divided by 24, and then x to the 7th. Okay, so that is the simplified answer. I can't reduce those coefficients in front of this expression. All right, so just make sure that you apply the exponent laws carefully, one after the other, and follow the bedmass rules to keep your order correct, and you shouldn't have any problems. Let's take a look at a couple of questions that ask us to evaluate expressions involving exponents. Okay, here are two questions that we're being asked to evaluate. We're being asked to show our steps and to not have decimal answers. So if we do get anything left as a fraction, a rational value, we'll just leave it as a rational value. So let's focus on the first one. We have a negative exponent. So if we recall, when we dealt with fractions, that negative exponent would get applied to each piece individually. So we would have 625 to the exponent negative 1/4 and 256 to the exponent negative 1/4. Both of those would carry a negative exponent, meaning if we move them to their opposite place, the bottom to the top and the top to the bottom, their exponents will turn positive. So I'm going to do that. I'm going to do that in two steps. I'm going to say this is really equal to 256 to the exponent positive 1/4 over 625 to the exponent, again, positive 1/4. Okay, now remember what a rational, that is a fraction, exponent means. Something being raised to the exponent of 1/4 is the same thing as asking for the fourth root of 256 and the fourth root of 625. And we can just use our calculator to go ahead and answer those questions. Either enter 256 to the exponent 1/4, and make sure you put the 1/4 in brackets, or if your calculator has a button where you can specify which root you're looking for, ask for the 4th root of 256 and the 4th root of 625. When we do that, well, the 4th root of 256 is 4, and the 4th root of 625 is 5. So there's the answer. 4/5 is the evaluated answer for that first question. Let's focus on the second question now. The second question has 3 terms. I see some negative exponents, I see a 0 exponent, and I see a rational exponent. So let's just take care of these one sort of step at a time. When I'm faced with a rational exponent, like 3/4, I can either type that right into my calculator, but if I'm asked to show the steps, that is to show clearly how I'm coming up with these answers, then I can just say, okay, well, I know that 16 to the 3/4 is the same as 16 to the exponent 1/4, and then all of that cubed. So I'm just going to break up the 3/4 into 2 parts. Okay? Then I'm going to subtract, well, 17 to the exponent 0. Well, any base to the exponent 0 is 1, so that's -1. And then I'm going to add, and lo and behold, I've got 2/5 to a negative exponent. Well, we learned from not 2 seconds ago that if I just change that, the exponent goes positive. Okay? All right. Well, what is the 16 to the exponent 1/4? What is the meaning of that rational exponent? Well, remember, that is asking for the 4th root of 16. Get that answer, and then cube it. Then we'll subtract 1, and then we're going to add, and this squared is 25/4. Because 5 squared is 25, 2 squared is 4, so there's our answer. All right, almost done here. The 4th root of 16 is 2, and you can just evaluate that on your calculator. And then 2 cubed is going to give us 8. Okay, so we've got 8 minus 1 plus 25/4, or 7 plus 25/4. Alrighty, well, looking for a common denominator, we'll choose 4. So 28/4 is 7, plus 25/4, and that's going to give us an answer of 53/4. Okay, and I cannot reduce 53/4, can't reduce that into anything lower, so we are done there. So there we go. Taking the exponent laws, we can apply them when we need to simplify expressions, and we can also apply them when we're asked to evaluate expressions.